Yeah, good evening everyone. So Johnny Camps, let's start off. Last thing we're doing is the junction law. Why so many people are missing today? Next thing. Kirchhoff's voltage law. Same thing as capacitors. Potential difference between 2 points. Is sum of potential difference across the elements. In any path between the 2 points. In a closed loop, the sum is 0 because you came back to the same point. So again, same thing. We use the same sign convention we used in capacitors. So when you go in a battery, -2 plus, when you go in a resistor, current I, or when you go in a capacitor. So basically charge always flows from higher to lower potential, same thing, current flows from higher to lower potential. So when you go in the battery, from negative to positive terminal, you write as +V. You go opposite to the battery, it is -V. If you go with the current, potential drops, -IR. You go opposite to the current because current always flows from higher to lower potential here. If you go opposite to the current flow, potential will rise. If you go from positive to negative plate, potential will drop. Again, flow of charge. If you go from positive negative to positive plate, it will rise. This is your convention. Convention is important. So we are keeping it pretty simple. When you go from higher to lower potential, it drops. So in the direction of the charge flow or in the direction of the current when you travel, the potential drops. Whenever you think of that, right, think of like this. You know, you're going in the direction of the water or river. River always flows from higher height to lower height. So let's say you're trapped in a cave and you're not sure which way to go. Generally, one of the technique is you leave some water and see which way it is traveling, go opposite to that because you want to get out of the cave. Generally, that is the technique. But unfortunately, if the cave is something like this, you're gone for case. That's the thing. So you will go like this and you'll jump inside. Can't do anything about it. All clear with this? Great. Now, you guys try a question this thing. We have done this with Kirchhoff's junction law. Let's try to do this with the KVL. I'll do one thing. I'll give the chart distribution so that we are all using the same equations. So current I comes here, small I goes here, and I minus I goes here. We will take this loop and we will take this loop. Find the currents. I just showed it to you how to distribute so that we can all have the same equation so we can check. Find the currents. But normally you can take whichever any battery is giving current I and you can split. You know the thing. Similar to the charge distribution there. Get the equations. Get the charge distribution. Current. Let's see the equations. I'll write for the right loop. Going through the battery, 2V minus IR minus I into 2R equal to 0. The left loop minus I into R minus V plus I into 2R is 0. Check, we have two equations, two unknowns. If you solve, you should get I is, yeah, most of you got the same answer, GB by 5. You can check that. Simultaneous equations, two equations you can solve. First, check your equations. If you got the equations right, then you'll get the answer. Matter of solving. Yeah. Anika, the answer you got now, think about it. The battery I have at 2V and VA. You got a voltage of 4V. That itself, you should feel like, yeah, something is wrong. All clear? It's easy. Let's see one more. Two volt, 10 volt, 2 ohms, 1 ohm, 2 ohm, 6 volt, 4 volts, 2 ohm, 1 ohm, and 2 ohm. This is point A and this is point B. Find VA minus VB. Others, do keep your cams on. 6 volt, yeah, I have a resistor there also. I forgot to give that. Take it as 6 ohm. There is a resistor behind this point I forgot to give. There are 3 resistors in each branch. Think, take a minute. Let's see. So the main idea here, right? First thing, there'll be no current in this branch. That is the first idea. You should figure it out. Because if there is a current in the branch, think of like this. If you say this current is some I1, the I1. Now, if you say the small I goes here, and this will be I1 minus I. Now, there is a problem here. The same amount of current is not coming back. Remember, battery does not produce charge. Battery simply circulates. It's like a conveyor belt, isn't it? It's like a conveyor belt. So what is happening in the conveyor belt here? Think of like this. I'm sending, let's say, a conveyor belt, the link, chains, whatever. It is going here and some chain is going this and remaining chain is coming back. Doesn't make sense. Eventually, the wire will start losing all the electrons and become positive charged. Things will be bad. So it doesn't work that. So the main idea here is current cannot flow. The two circuits will behave independent of each other. So this I1 will simply go here. Similarly, whatever current flows here, I2 will simply flow in this. Because by chance, if the current goes into the branch, there is no way it is going to come back. So that is the main thing there. So current in this branch has to be 0. Since current leaving the battery must be equal to current coming back to the battery. If I is not 0, then I1 leaves 2V, but I1 minus I returns. So charge is not conserved, doesn't work. That is the main idea there. So once you got that, you can just ignore that branch. Find the current here. I1 would be, apply Kirchhoff's law here, 10 plus 2, that is 12. Both the batteries are in the same polarity. By 6, that is 2 ampere. I2 will be 6 by 9, 2 by 3 ampere. And now you want to go from A to B. So let's take this path. We will go in that path from A to B. So start from A, VA. Then you're going opposite to the current. So minus plus I1 into 2. Then you're going opposite to battery, minus 10. Then that current is anyway I into 2, which is 0, minus 4. Then you're going again opposite to current plus I2 into 2, and you have reached B. You're getting it? You start from A and you go till B and you add everything in the middle. So this is how you start normally. You start from A, VA. It's like this, think of like this. Let's say you're already at a height of 200 meters. So this has become like this, 200 meters. You jump down a step of 2 meters, so 200 minus 2. Then you went down one more step, -1. Then you went up 2 steps, +2. Then you went down 4 steps, -4. You're adding. Finally, what is your height? Something of that sort we are doing. So we started with the potential at A, VA. Then when you went through this 2 volt, 2 ohm ka battery, 2 ohm ka resistor, it become plus I1 into 2. Then when you went through the 10 volt battery, it is -10. The 2 ohm won't matter anyway. The 4 volt is -4. That is plus I2 into 2. You can substitute the values here. VA. This is 4 -10. This guy is 0 -4, and I2 is 2 by 3, 2. 4 will cancel. You get VA minus VB is equal to 10 minus 4 by 3. That would be 26 by 3 volts. Did you guys forget the 4 in the middle? Even though there's no current in that battery, the 4 volt will matter. Be careful with that. That branch connecting has a battery, so -4 aayega. Do have a look at this. So you need not always complete the loop. You can start at some point and you can just stop anywhere else. I mean, just for your thing, can you tell me what about this guy? If I start from here, 0.1, and if I end up here, can you just tell me what will be the answer for that? Start here, and I want here V1 minus V2. Try. I'll give 30 seconds. There go. I'll start from V1, then I'll go I1 into 3, then I'll go to 2, which is anyway 0, then I'll go -4. I'm going like this, the black line. And then I'm going with minus I2 into 1, I reach 2. This guy is gone. So V1 -3 into I1 is 6, -4, -2 by 3 is V2. This is 10 plus 2 by 3, 32 by 3. You can use Kirchhoff potential also. What will you do if there are like 10 resistors? 32 by 3, no? Right? Yeah, 32 by 3. Check. So you start at 1, you're ending at V. So V1, then you keep adding or subtracting according to the sign convention. Then you reach V2 finally. Once you reach 2, you just stop there. I hope everyone's clear with this. Clear, na, Yasha? Adrit, got your mistake? It doesn't matter. Any path you take, answer same answer. Meaning you can go like this, you'll still get the same. Just because you get different path, 1 and 2 will not change their potential. So it shouldn't matter. Must have messed up the sign somewhere. Clear? This is a good one. Not a tough question, but you should know that current won't flow in the 4 volt branch. But when you go through that, there's a -4 ka potential difference. This we did in capacitors. Now, these are the kind of questions, Kirchhoff's junction law, you'll go mad. I hope you found where is I1. I1 is this guy. This is I2. Get this thing. Find I1 minus I2. All resistors are 4 ohms. All batteries are 10 volts. Maze. Option A, option D. We have two different answers.
Sorry.
Let's see. So first let's find for I1. I will go like this. There, that is the loop. So minus I1R, then you went through a battery plus V. I'll just write as E as a battery EMF. V plus V plus V minus V plus V minus V equal to 0. So this is gone. So I1 is 2V by R. This is 20 by R is 4. That's 5 amperes. That's I1. Now here when I go, remember this entire thing R equivalent is how much? R, and this is R by 2. This entire green thing is 5R by 2. Then you go like this. I have to go like this only. But this here I'll take a diversion like this. So here the equation would be minus I2 5R by 2. That whole thing is a 5R by 2. And then plus V plus V. Yep, and you're back. So I2 is 4V by 5R. That's 40 by 5R is 22 amperes. So you want I1 minus I2. That's 3 amperes. Check. This is a maze. We have done this before. So the main catch in this kind of questions is make sure you're going through that one resistor, and you can go any number of batteries, it is fine. Because when you go through a battery, it doesn't depend on what current it is. But if you go through a resistor, current starts mattering, and I can't find current in every branch. Clear? Any doubts on this? Next one. Let's say we have 4 microcoulomb minus 4 microcoulomb, 2 microfarad. This is point A. This is 2 ohms, and the current is 2 ampere. This is 3 volt. This is 2 ohm. This is 5 ampere. This is point B. This is 1 ohm. This is 6 volts. 3 volt. Let it be 6 volts. This is minus 3 microcoulomb. This is plus 3 microcoulomb. This is 1 microfarad. This point here is grounded. This is point C. First thing, find VA, VB, V7 done. If you find these 3 jobs done, you get everything. There, capacitor, you have the battery, resistor, everything. So Kirchhoff's law works properly. Even if you have multiple elements, you can use this. Try. You got 2 minutes. Mm, 0 minus 19, 3. Okay, we have two answers, same 0 minus 19, 3. First thing, because this is 5 ampere and this is 2 ampere, this should be 3 ampere, junction law. So there's a current in that branch, so you calculate from there. Next thing, you said this is 0 volt, fair enough. So C directly aa jayega. You can go from 0 to C. So this is 0. You're going from negative to positive plate, so that is plus 3 microcoulomb by 1 microfarad, and you reach C. So VC is 3 volt. You directly just go from O to C. Then let's go from A to 0. So let's start it here, VA. Then I'm going from positive to negative plate. So minus 4 microcoulomb by 2 microfarad. Then I'm going through the 2 ampere, minus 2 into 2 ohms. Then I'm going through the battery minus 3V. Then I'm going through the 3 ampere ka thing, but that is positive because I'm going opposite to the current. Then I went through the battery 6 volt and I finally reached 0. So I went from A to O. Because see that I know already the potential 0, right? So let's take everyone from A to O, B to O, and C to O. That would be the best thing to do. I mean, we could have done that also. This is from C to 0. That will be Vc minus 3 microcoulomb by 1 microfarad. 0. So Vc is equal to 3. This is Va minus 2 minus 4 minus 3 plus 3 plus 6. Yeah, Va is 0. Then let's go from B to 0. VB, I'm going opposite to the current, so 5 into 2. Then again I'm going opposite to the current, 3 into 1. Then I'm going with the battery, 6, I reach 0. That's minus 19. Clear? Easy? Let's see one more. Any doubts on this? So let's go from A to 0, the thing which you're grounded, so that'll have a 0 potential. Start from there. Next one. This would be even better. This is 3 ohms. Let's call this thing A, B, C. This is D. This is the positive plate, which is Q1 is equal to 2T. Charge is not constant. This is the charge on this plate, Qt is equal to 3T. This is 2 microfarad and this guy is 1 microfarad. This thing is 5 volt, 2 ohms, 3 volt, 1 ohm. I can give any numbers, doesn't matter. This thing is 2 volt and this is 2 ohms. And I know in this branch the current is 1 ampere. That much information I have. Maybe I'll use a different color, almost red. So current in this branch is 1 ampere. Yep, other branches nothing is given. Find VA, VB, VC, VD.
So the charge is not constant, right?
Yep, T is time. This is actually a non-steady state. I told you steady state meaning what? The charges and the currents become constant in the branches. Why did it get erased in the middle? Yeah. Try everyone. Let me give you value actually at T is equal to 2 seconds. Or else you'll get as function of time T. Now I can do a function of time T. It'll be a little complex. Let's find that T is equal to 2 seconds. Find VA, VB, VC, VD at 2 seconds. Try. This is a good one. Then do it now. If you think it is like previous one, then do it. And then tell, right? It is like the previous one. It's like when someone comes and tells, na, money is not important in life. First you earn and then you say. Problem is that a beggar coming and telling money is not important in life. So that's a problem. Think it's a previous one and try, you'll get stuck. You'll realize something is missing. Hmm. Let's see. People saying we don't know how to find the current. Should go back to the first page. On the left hand side, in the red box, there is something there which tells you how to find current. It's an alphabet between P and S. If you take that and differentiate, God gives you something. So if you look at this branch here, look at this. If I say this current is I1, I1 is nothing but dq1 by dt. The reason the charge is increasing on the plate is because of this current. Similarly, there's a current in this branch I2, which is I2 is dq2 by dt. That is how you find the current. That's a 3 ampere. Since you said that t is equal to 2 seconds, this thing has a charge of 6 microcoulomb. T is equal to 2 seconds, this thing has a charge of 4 microcoulombs. There is a charge, but it is changing. So at t is equal to 2, these are the currents and these are the charges. Now it looks like the previous problem. So the catch here is to find the current first of all. Since this guy is grounded, let this guy be 0. So let's go from A to 0. And actually I need to find the current in this branch also. How much is this guy? So you're saying I1 is 2 ampere. I2 is 3 ampere. So 3 is coming and going. Luckily in this thing, current became 0. Current in that branch is 0. Because this is 1 and this is 2 and this is 3. I should have given it different numbers, but okay. I wanted some current in the branch, but no issues. So there we got this. So current in that branch is 0. Let's go from C to O, VC. Then I'm going 0 into 2. Then I'm going minus 2 is equal to 0. VC is 2. Then let's go from A to 0. C again, I'll go from B to C, A to C. VA, current is coming, remember, this way, opposite to the flow. So plus 2 into 3. I'm going from negative to positive plate. So plus 4 microcoulombs. Four microcoulombs by the capacitance is 2 microfarad. And then I reach C. So this is VA plus 6 plus 2 is equal to 2. The VA is minus 6. Then let's go from B to C. Let's go from everyone to C only because C ka value I know already. So VB going through a battery 3B going opposite to the current plus 1 into 1. I reached VC. VC is again 2. 2 minus 4 again minus 2 volt. Let's go from D. So VD. I am going from positive to negative plate. So 6 microcoulomb by 1 microfarad, that is minus 6. Then I went through the battery plus V. And then the current here is 1, how much is this? 3 ampere. I'm going through this thing. So that is minus 3 into 2. I reached VC. So this guy would be VD minus 6 plus 5 minus 6 is 2. That is 12 to 14. 14 minus 5. VD is 9. Check. This is how they can ask questions on Kirchhoff's law. These are the kind of questions you should be like thorough within KVL. The circuit solving and all is fine. That you can handle even with junction law. Even here you could have used a junction law, but yeah. You literally then you'll jump across each branch and you'll find basically problem with junction law here is there are too many nodes. You'll find C, then you'll find here, then you'll find here, then you will find here, then you'll find here, you'll find here, then you'll find here, then you have to literally find across every node. Same thing. Technically speaking, both are the same concept, just the way we look at it. There we say total currents are 0. Here we say the total potential is 0, or the sum of the potential difference is this. All got this? Now, there's also something called color coding, which is removed from the portion from main. So we won't be doing that. And then there's also something called star, delta, and all. We don't need it actually. That they teach you in electrical engineering second or third year if you go to IIT. So you don't need it. Matlab, you saw with the techniques that we know, right? You can handle most of the circuits. And generally in exams like JEE and all, they're not trying to test your, equation solving skills. They're trying to test you. Can you observe the symmetries? Can you see some patterns, or can you try to figure it out? That's it. So the star, delta, and all is all good. Meaning sunne mein acha lagta hai, but problem kya hai na? Already you have enough things to remember. So that's what I keep saying. Let's say if there are two techniques. One technique will give you answer in 3 minutes. Another technique will give you answer in 1 minute. But the second one is more lengthy and confusing. There's a good chance you'll goof up something. Better you do the 3 minutes one. That you have enough time in the exam. Anyway, you're not going to, planning day to go and score 100 marks. As long as you put more than 70%, you have that, the bandwidth of 30%, which you can leave it if you feel it is too tough. Your job is to score that remaining 70. So star delta is not important. If still someone wants to see, you can just search it, you'll find it. Next thing, steady state. Max to max, I feel like, if at all they want to ask you something in circuits, literally solving, this is a kind of question they can ask you. Question is weird. The moment you see it is scary, but you can handle it in 3-4 minutes. फिर भी तो कुछ पूछना है. This is also a little on the higher end. I would say this is a better one. This was still a good one. So they will give some kind of symmetry to make it simple. You can handle in 2-3 minutes. Don't worry about that. So next thing, what is steady state? This we know. We have discussed this multiple times. This is the third time. First time we discussed this thing in heat transfer. Steady state meaning the temperatures or the property becomes constant. Then we saw in this thing Bernoulli's equation, steady flow, streamline flow. So if the property at a given position does not change with time, so steady state doesn't mean all will have same values. Everyone can have different values, but they should not change with time. At a given position does not change with time. We can see the system is in steady state. So in case of circuits, the currents, voltage at the nodes, and the charges on the capacitors must remain same. So here in circuits, charges on the capacitor, voltage at nodes, current in the resistors do not change with time. So in circuits, that is the meaning of steady state. So therefore, if you take a capacitor and if you say the charge is going to remain constant, now again, when I say steady state, doesn't mean charge on the capacitor is zero. So capacitor in steady state, Q is constant. Therefore, the current entering the capacitor has to be zero. In a steady state, current doesn't flow through the capacitor. And we will see the reason also why it works that way. Meaning, this is the same thing as induction. If you remember, initially, the moment you close the circuit, there are no charges on the capacitor plates. So if a charge is trying to come, they will be like fine with it. No one will oppose you. So at T0, when the capacitor is completely empty, the charge will just pass through it. Sit straight, everyone. Don't bend 90 degrees, 120 degrees. Sit straight, focus. Nothing goes into the head. Or you're trying to put your head to the ground and get grounded. Zero potential, something of that sort. Don't do that. When you're learning, sit straight. Next thing. I'll give you a break, na 10 12 minutes. So then just go and sleep on the bed. Best thing, I don't know what you guys do in the break. You had a break, the first thing, get out of the room and go and see somewhere little far, see the sky or something. One of the reason I give you a break for that. If you keep just watching the screen for 2.5 hours, you'll stop, you'll forget to blink your eyes. That's the first thing that happens. And when you forget to blink, normally we blink like every 10 seconds or something, but when you're looking at the screen, it drops drastically. Maybe you blink only like 4 or 5 times. Normally you blink maybe 10, 12 times. So your eyes won't get, enough lubricated, they become dry. So this is what happens when you have a capacitor here. At T0, they're empty. So when the current is coming, they're fine with it. They'll just let the current pass through. But as the charge is accumulating at one point, you have so much charge. If a new charge tries to come, it doesn't let the charge flow. So a capacitor in steady state is already like full. It will not let any more charge pass through it. So this is how they behave. At T0, for uncharged capacitor, It offers no resistance because there are no induced charges. So it behaves like a wire for an instant. So if you have a capacitor, you can just make it a wire at t0, only for that instant. At t infinity, long time, it is full, so it won't let any more charge flow. So this behaves like an open circuit, basically infinite resistance. Okay, that is since the capacitor is already full, the charges on the capacitor won't let any new charge come inside. There. So this is how a capacitor behaves in a steady state. At t0, they become like wires. At t infinity, it becomes a open circuit. What happens in the middle? We will see that later on. Let's see a question. So V, C, R, 2R, R, and C. So this is a switch. Find the current. Find I at t0. In the moment you close the switch, and t tends to infinity after a long time. And find charge on the capacitor in steady state. That is infinity. So if you give a long enough time, the capacitor will accumulate so much charge, it won't let any more new charge come inside. Let's get this. The moment you close a switch, find the current in the battery, and after a long time, find the current and find the charge on the capacitor after a long time. Initially, the anyway it is zero. Let's see. Hmm. So just draw the circuit. At T0, capacitor will act like a wire. It will be like this. So R, 2R, R, this is V, this is I. R equivalent will be 5R by 3. So I is equal to 3V by 5R. Now at T infinity, now whatever current you send here, I, all that will go through this thing. So in this branch, the current is 0, but remember there's a charge on the capacitor. Current is not there on the branch, but there's a charge. So here R equivalent would be 3R. The current I would be V by 3R. Current only flows in that branch. And to find the charge on that capacitor, I can apply Kirchhoff's loop law. I will apply loop law in this thing. That would be minus I into small r minus Q by C plus I into 2R equal to 0. This term is anyway 0 because small I is 0. So Q is equal to V by 3R into 2R into C. 2CV by 3. That's how you find the charges, everyone. Assume the charge Q on the capacitor, and in that branch, make the current 0. It's an open circuit, right? So doesn't mean that means current won't go in that branch. It doesn't mean there is no capacitor only. Capacitor is there. It will stop act like an open circuit. So don't take any current in the branch, but take charge on the capacitor. Clear? You can just apply Kirchhoff loop law in that, and you'll get the answer. Let's see one more. Again, find current at T0 to infinity and charges on the capacitor in steady state. Yep, this is a pretty nice circuit. It becomes from series to parallel, parallel to series. What about the charge? That is an interesting one in this. Current is easy. Try. I'll give you a minute more. Get the charge. See. So at T0, the capacitors become wires. Basically, all are in parallel. R equivalent is R by 3. Current is 3V by R. At T infinity, don't remove the capacitors, keep them because you will not get charged then. Just say current is not flowing in them. This is I, this is I, this is I, and this is I. Let this charge be plus Q. Let this charge be, you can take Q1, Q2, but I know they'll be equal. So you can take Q1, Q2, and 6. So you can apply Kirchhoff's loop law in this, Kirchhoff's loop law in this. Let the Q1, Q2, big deal. I guess it doesn't matter. You can assume anyone is positive plate. You can take anything as a charge Q1, Q2, and then see what happens. So first thing, the current in the circuit would be all three are in series. R equivalent is 3R. I is equal to V by 3R. Generally, the biggest confusion people get is that charge only how to find. So assume some charge and use Kirchhoff's loop law, you'll get it. So in that loop, if I go minus IR plus Q1 by C minus IR equal to 0. You get Q1 is equal to 2IR, so 2V by 3C. You do the same thing for Q2, you'll get the same thing. I wrote wrong, wait. 2 by 3 CV. Yeah. I hope everyone is clear how to find the charge distributions.
So in this one, I found the potential difference across the plates of the capacitor and then I use CV.
Chalega, same thing. Clear this? Let's see one more. Find the charges on the capacitor at T0 and T infinity. Not the charges, wait. Find the capacitor at T infinity. Just let me add one more resistor here. Find I at T0 and infinity. Let's see. It's at T0. At T0, what happens? The moment you close this, these two will act like wires. This whole thing gets shorted. These two are gone. Current will simply go like this. They got shorted. At T infinity, current will flow only in this. This will have some charge Q minus Q1. This will have Q2 minus Q2. So I would be V by 4R. Apply Kirchhoff's loop law in this, loop law in this, or you can say, that C is parallel to that R. They should have same potential difference. So this was C and this was 3C. So Q1 is simply C into the potential differences I into R, which is 4 CV by 4. Similarly, Q2 is 3C into I into 2R, which is V by 2, 3CV by 2. Check. Hope you're getting how to play with steady state. So be careful with that. This is steady states, meaning T0, T infinity, straightforward, general mains level questions. Let's see what happens if you ask as a function of time t. Any doubts on this? Please ask me. Next thing. RC charging circuit. This is important. Whatever techniques you learn here, we're going to repeat them again later on, something called LR circuits, inductance and stuff. So let's see how this works. So let's say we have a capacitor, we have a resistor, we have a battery with a switch. At T0, you closed it. Then after some time, intermediate stage. So suddenly charge won't come. It will take time. Let the current be I and let the charge be Q. We know here I is equal to dq by dt. And apply Kirchhoff's loop law. V minus Q by C minus IR equal to 0. So this guy would be CV minus Q by RC is equal to I, but I know I is dq by dt. So this will be dq by CV minus Q dt by RC integrated on both sides. This is 0 to 2. This should be actually Q initial, but Q initial is 0 to Q. That would be minus ln CV minus Q is T by RC. So substitute that, you end up with Q is equal to CV into 1 e power minus T by RC. And if you want to find current, just differentiate this dq by dt. You end up with V by R e power minus T by RC. Yeah, so it's not a constant, it's an exponential function. So if something comes, this is how you proceed. Let the current be I, let the charge be Q, apply Kirchhoff's law and integrate. This is a brute force. And this is like the technique, this will work. It might be complex, but this will work. Later on, I'll show you a simpler version. There is a way to figure out this much faster. But have a look at this integration. Any doubts? So if you try to plot a graph for this guy, Q versus time. So we have Q is equal to CV into 1 e power minus T by RC. Remember, this is initially, Q initial should be 0. If you have initial charge on the capacitor, this is gone. So this is an exponential function. So this is CV. So your graph is getting closer and closer, but it'll never touch there. So if you take a point here, 0.63 CV, you get something called tau. It's called time constant. This is the time taken to charge the capacitor by 63%. No, what is so special about this is nothing actually. When you put T is equal to RC, you'll get a good number there, e power minus 1. That is the reason you'll get that 0.63. You're getting it? So if you put time constant there, you end up with Q is equal to CV into 1 e power minus 1. So that CV is 1 minus 1 by E. This value was 0.63 CV. So there's nothing special about that 0.63 CV. That's just e power 1 ka thing. Same thing if you try to plot. So remember the time constant. This thing kind of looks the same, similar as relaxation time. And if you had plotted I versus T graph, this would be an exponentially decay function starting at V by R. This is also the same idea, 0.37 V by R. So in one time constant, current decays by 63%. No, this is not half-life. Half-life is something else. Half-life is RC discharging circuit. Have a look at this. So the graphs are important. The formula is important. Exam like mains or bits, they will generally won't go beyond. They won't try to mess up anything.
We should derive this in the exam, or we should just remember the result.
If you can remember, it is good. If they change something, then you should know how to derive.
Yeah.
So depends on the exam you're writing. If it's a mains exam, if you don't remember, you'll be slowed down in the exam. Bits exam, you'll be slowed down. Mains फिर भी कर लोगे. Bits में problem आएगा. Because bits में out of 390, if you don't score at least 331, this year का cut off the 331 bits पुरानी CS. There are two of your seniors. One guy got 329, one guy got 324. दोनों को bits गोवा CS मिल गया. 2 मार्क में पिलानी चला गया. One guy got पिलानी CS actually. उसका 331 है. So अभी 390 में मतलब 130 questions in 3 hours. Mains is only 75. So there you won't have time to derive. And if you can actually remember a bit, it helps. Mains or advanced also, if you can remember certain results, you'll have time for more tougher questions. So now you need to see. For me, I have a very simple rule. If I can't derive in something in 45 seconds, I'll remember it. That is how I finally decided, like in 11th and 12th. If I can't derive something in 45 seconds, I'll remember it. बस हो गया. Because with the kind of, I had an aversion towards remembering stuff. I really hate remembering things. Yes, but Socho, my inorganic was one of the best. Because the rule was simple. I had to remember not because I like it or not. It is important. Without inorganic, I know I'm not going to qualify. Doubting nahi hai. So I just kept my mouth shut. Whether I like it or not, I just studied it. And that is the thing you need to important. Extra questions are still there. If you do all 130 and submit, you'll get extra 12 questions. My time we had 150 questions in 3 hours. So, and you had to do all 150 and submit, then you get extra 12 questions. Generally, what I notice, people who score 320 plus, they attempt extra questions. Without that, it becomes a little difficult. Take a break. Come back by 7. We'll continue from here. 8 out so far. No extra time, right? You have to write everything in 3 hours only. Shall I come back by 7? Next thing, RC discharging circuit. In this, you take the capacitor which is already charged. And you close the switch. So here, let the charge be Q, let the current be I. Now I will be minus dq by dt since Q is decreasing. Apply the Kirchhoff's loop law. We get a Q by C minus IR is equal to 0. Integrate this, you end up with Q is equal to e power minus T by RC. Q versus time and I versus time. The graphs would look identical. This is Q and this is Q by RC. Same definition, time constant means a 63% decay. So this is how a discharging circuit looks like. Now, if you look at this thing actually resembles your first order reaction, N is equal to N naught e power minus lambda T. Did you study that in chemistry? Radioactive decay, first order reaction in kinetics, chemical kinetics. So it actually resembles, it is the exact same thing. Matlab sirf lambda ka place mein 1 by RC. So here T half life will be ln 2 by lambda. So here also you can see something like that. The time when the charge becomes half is ln 2 by lambda. Lambda ka place mein we have RC. 1 by RC. So this is RC discharging circuit. Let's see our question. Comes on everyone. We have a capacitor plus Q minus Q.
Can you show previous page?
Done? Done. Switch here and this is R. Straightforward question here. Find time when charge becomes half. Find time when energy becomes half. Find time when current becomes half of maximum. You can take it as 1/3. That is better. 1 by E times. Get them. Just formula substitution. There's nothing there. And you have seen this somewhere else also. Do you remember where? Amplitude is equal to A naught into E power minus BT by 2 damped oscillations. Remember? Damped oscillations is something like this exponential function. Means when they removed it, but yeah. Let's get this. Let's see. We know the formula Q for discharging is Q into E power minus T by RC. So the first one, Q becomes Q by 2. Put ln on both sides. You end up with T is equal to RC ln 2. The second part, we know energy is nothing but Q square by 2C. That means for half energy, Q must have become Q by root 2. It was the exact same question in damped oscillation. Energy half and this thing. So Q by root 2 is equal to Q into E power minus T by RC. Q get cancels, put ln on both sides. You end up with T is equal to RC by 2 ln 2. Third is what? I is equal to Q by RC E power minus T by RC. You're saying when the current becomes 1 by maximum times, so it becomes 1 by E times Q by RC. Basically one time constant. It's not 1/3, so yeah. 1.23. Yeah, you can calculate ln 2 ka value. Ln 2 kitna tha? 0.693 something, na?
Yes, sir, 0.69.
0.7 by 2 something. Yeah, so you can round it off 0.35 RC. Easy. This would be mostly a mains level or a bits level question. Let's see something. Going ahead, any doubts on this? What if R1, R2, R3, we have a switch here. The switch can be flipped between A and B. This is capacitance B and this is there. Initially switch is at A for a long time. Then flip to B. Then, so flip to B at T is equal to 0. So you're flipping the switch to be at T0. Then find current in the find charge on the capacitor as function of time T. Now approximately draw QT graph if switch is flipped between A and B for small time interval. Meaning you kept it initially it's at A, then you flipped to B for small time, then you came back to B for small time, and so on. Is flipped between A and B. With the time interval. Means initially it is at A, fully charged. When you go to B, you'll discharge. You come back to A, you'll charge, discharge, charge, discharge. This just keeps going on. So how will the graph approximately look like? I can give you values, but let's see. I can even ask you like this also. Find the time constant while charging and discharging. Yeah, then first is easy. Third is also easy. Second, you have to think a bit. You want an approximate graph.
What is the time interval?
Time interval, bus. What will do with time interval?
Now, if I take it at tau and
लेके देखो वही बोला ना. Let's see. It don't matter.
I can take it infinity also.
ले. So draw all the graphs from starting from 1 second to infinity. Just finish off infinite graphs and then you're done with the question. Said an approximate graph. Let's see the first one. So initially when it is at A, it is fully charged. So this thing will have a charge Q. Q would be CV. That doesn't depend on R1 in this thing. So if you look at the time constant initially, that is R into C. So here it is R equivalent is R1 plus R2C. This is a time constant during charging. Now the moment you flip the switch, the battery is useless. This guy will start discharging. Now this big Q, current will start flowing this way. Now the time constant during discharging is, now R1 won't come in the picture. R2 plus R3 into C. And we can find Q is equal to Q into discharging circuit to E power minus T by RC, where R is R2 plus R3. I'll just write it as tau. Till here it is fine. This was the easy part. Now when you're flipping it front, back, front, back, front, back, what is happening exactly? Let's try to guess. Initially, you're already at some Q, right? And then it starts discharging. The moment you flip it for a small time interval, now this is the thing, yeah, that it won't matter. Why? Because even if you take infinity, this is going to take infinite time to discharge. So if you just take a random t, meaning you can just stop the graph somewhere here. Let's say that is some random time t interval. And then what happens? Suddenly you flip it, now it starts charging. Right? So how will that circuit look like? So if you flip it back, now you start charging. Now the equation would be slightly different, but we know definitely it will be charging. But think of like this. If you just leave it for a long time, what will happen? You will try to reach here. Won't it again start charging up? Is that making sense? And then again you flip the switch. But remember, again, to reach the same value of Q, it will take infinite time. The point is that to completely discharge will take infinite time. To again go back to Q will take infinite time. So this thing will increase. By that time t is already over. Again, you'll start discharging. I'll do one thing, I'll just change the colors. So this is the charging part. Then now again you will discharge. But the catch here is you won't discharge as much as before. You're getting it? Because for the same time interval, if you're discharging, think of like this. Let's say from here, you discharged by to half, example. Whatever is here will discharge to half of this value, no? And then again, you will go up. Again, you will charge up. But this will be definitely greater than the previous one. Again, you'll discharge, but it is less. Again, you will charge up. You will discharge. You're actually getting closer and closer to that. Yeah, it just keeps getting closer and closer to that Q value, but it will never reach. The graph just keeps going upper and it just keeps going higher. Is this making sense? Because see, every time it will discharge by the same percentage. Think of like this. Let's say initially you are 100. Now the time interval t, example, let's say it is 50%. So 100 becomes 50. Now in this time t, again, like I said, you won't, to go to 100, it will take infinite time. So let's say in another time t, the 50 ka value went to 80. Now what is 80 ka 50% again? 40. But now when you charge again you'll charge by, let's say, some certain amount, let's say maybe 40 or 45. Again you'll go to 90. Again you'll go to 45. Then again you'll go to 95. Again uska half, 98. Again uska half. You're getting it. End of the you're trying to reach 100 again.
So in this case, 40 is less than 50 now.
Yeah, was कुछ wrong दिया रहा मैंने 60 लेना.
So, but how is it 60 now? 100 से 50 हुआ तो 80 से 40 होना चाहिए.
I wrote wrong. तो check कर ले. You're saying it will discharge more 50% of it, no?
It can discharge more. Now, what is the problem in that?
Solve करना पड़ेगा. For simplicity, if you just take one time constant, this would be how much? 0.37 Q.
0.37 Q.
So whatever is this, इसका 0.37 Q should be even
It could
lesser.
be below that 0.37 Q.
It could be lesser also. Low हो सकता है.
It will depend on values. So if it is lesser, it means the graph will go towards 0. And if it is not, it will go towards Q. How do we tell that?
You have to take both the possibilities. Calculate कर लेते हैं इसमें क्या है? That's why I didn't give the time interval.
It
Could
will
be
depend
anything.
on R2 and R3 का values also now.
बहुत depend करेगा, but let's see. So let's say initially when you're charging, let's check the time constants as T1 and T2, na? And time interval as T. So let's see what happens.
So T is less than T1, T2 or more than T1,
What
T2?
if let's say time interval is much smaller? Let's do for a very small time interval. Then
Okay. Yeah, we can do that.
if you take for a very small time interval, then you're not discharging fast enough. Then you will discharge only this much.
Yes, so.
Then again you will charge, but you won't go to the same value. अभी सिर्फ doubt ये है, how much will I discharge? That we need to solve once. Let's see. Let's say after time t, इसका charge becomes Q, where Q is nothing but Q into e power minus t by RC. This is your initial charge. Now you're putting a battery. Then now what will be the charge? Now that formula is only not valid. We have to again derive. Isn't it?
Yes, so.
So let's say इसका value Q by 2. Example ले लेते हैं. So now if I try to integrate this, what will I change?
So
This
we'll
would
have to
be
use
V
KDL again now.
minus IR. हाँ, पूरा integrate करना पड़ेगा. Minus dq by dt. This will be dq by that q by c dq by dt.
In the
So
previous
that will be
integration, you
CV
can just
minus-
put other limits as Q
limit
by
से
2
change
to Q.
करना पड़ेगा. Yeah. This would be minus ln CV minus Q by CV minus Q by 2. T by RC, CV minus Q would be CV minus Q by 2 e power minus T by RC. You get Q is equal to CV minus Q by 2. CV is actually Q only. That would be Q by 2 minus something you will get. So you will get less than half actually. What if this value is Q by 4? Then this will be Q minus 3Q by 4. It will be less only, right?
It will always be less.
It's always being less actually. We need to think about this एक बार. Chalo, let me think about that. You guys do one more problem. So is there no case where it will go to the top thing value there? That's a good one. Let's see next one. Let's say we have a capacitor with a resistor with a switch. This is R, this is 2C, this is C. This is plus Q, this is minus Q. This is minus 3Q, and this is 3Q. And the switch is closed at T0. To find the charge on this plate as function of time t, the right plate of 2C. Like here, there's no battery only. Both are discharging. Yeah, it's only discharging here, but you can't use the discharge curve formula. There are two capacitors na, here. That will always decrease, right? इसमें ना दो cases है. If I want the answer which I want ना, we can change that. See, if initially, it depends actually on initially where did you connect. If initially switch is at A, means you're already charged. So then the diagram would be you're already full, you will discharge till you increase. You will actually start going down. You will increase, but you can't reach up again. You will tend to zero. What Ishan said was right. And this just keeps going down. But if initially switches at B, that is capacitor is empty, still think about this more. It's a pretty good one. I don't see how it is not depending on time constants. So it will first charge. Now it will decrease 0.63 of this, means you will not come to 0. Now you definitely have to go up. Then again you will discharge. Now this thing will start climbing up. I think this is the graph I draw. And eventually you'll try to reach that whatever value it is.
But how do you conclude it will go up more than the
Mhm.
initial value it started with?
Because if you, for example, think of like this. If it is one time constant, you will always charge 63% of the value.
Yes, so.
So initially when you're empty, you went to 63%. Now you already have something, plus you're going 63%.
So, but that 63% is different now.
So सोचो ना, when it is empty, it will definitely go more than that. मतलब मैंने calculate किया, you're getting some extra plus something you're getting. You're getting something like q into 1 power e minus t by rc plus something you're getting. So that's a very bad value, whatever, but plus something आ रहा है.
Okay, then.
So check करके देखो एक बार. So initially empties, I think it should be like this. But think about more possibilities. I think I didn't think enough on this. This thing I just made it up. I gave this question, but then I thought flip भी कर लेते हैं ना अभी. I just made up the question. So let's see. Even I need to think more about
It's
that.
kind of
Let's see
like
if there
our
are any
phone
other
charging.
possibility. Huh?
It's kind of like phone
Actually,
charging.
I wanted something like this actually. But I don't know how to create this. सोच रहा हूँ.
So could we say कि in a steady state at time infinity with the flipping, it will be like both of them are the same point.
नहीं
So,
वो अभी
अभी detect
वो
1%
टाइम
for
वो
one.
टाइम इंटरवल चेंज करना पड़ेगा. When it is at A and B, I need to change the time interval. I can play around with that. If you give same time interval, there are only two options.
So
I
again,
need to
here
say
also now. So here we are taking tau 1 and tau 2.
सोच के आओ. नहीं
Okay.
tau 1 tau 2 will simply talk about charging and discharging. What
Yes, sir,
matters
but
is
in the
time interval.
charging process, the time constant is different, and in
फर्क
discharge
नहीं
it is
पड़ेगा.
different, na?
फर्क नहीं पड़ेगा. To reach infinite, it will still take infinite time. To reach q, it will take infinite time. To reach 0, it will take infinite time. Your time constant will simply tell you how fast you're reaching that value.
Yes, sir.
So what matters is the time interval. Like Adit was saying, time interval matters. But then again, if you change the time interval when you're at A for let's say t and you're at B for 2t, then your game will be different. But then R1, R2, R3 may be depend karega. There are just too many variables. Let's see. I also need to think about a bit about that. Let's get 27. But think about that. That's a pretty good question.
I think we can at least make the resistances all equal.
कर सकते हैं. Then the time constant equal हो जाएगा दोनों का.
Yes, so that will be much better to solve, I think.
Give it a try. Next class, I'll see if I make something. I'll ask in the class. What is the answer for this guy? 3q e power minus t by 2rc 2cr ln. Why did you find time, Raisel? I told you to find time as a charge as a function of time, Aryan. You found something else. So this is how we play with this. Let this charge be q. Let the current be I. This is R. This is I. Now remember, the total charge on this plate and this plate is constant. That means on this plate, the charge should be 4q minus q. Agreed? Total charge is conserved. Charge so conserved hai na? Whether the decayed, not decayed, doesn't matter. This plate and this plate are isolated. The total charge has to remain constant. Apply Kirchhoff's loop law. I'm going from negative to positive, q by 2c minus IR. Then I'm going again positive to negative plate, 4q minus q by c equal to 0. Q by 2c minus 4q by c plus q by c is IR. And remember, I is minus dq by dt because charge is decreasing. This would be 3q by 2c minus 4q by c is R into dq by dt. So dq would be 3q by 2 minus 4q is dt by rc. This thing has charge initially 3q. This will go till q. This will go from 0 to t. Be careful with the limits. Don't put 0. The q is a
This is
charge on the
minus
right
dq
plate.
by dt, no?
एक minus भी आएगा. And then integrate this. How much is this? 2 by 3 ln 3q by 2 minus 4q minus t by rc. Three q by 2 minus 4q by 9q by 2 plus q by 2 minus 3t by 2 rc. Four q plus q by 2 e power minus 3t by 2 rc. 2 by 3, so that is 8q by 3 plus q by 3 e power minus 3t by 2 rc. Check. Yeah, actually, and I got the same. Anyone else got the same? Got the steps? This is what I was saying. You give me something weird. If I have one resistor, one capacitor, your life is easy. The moment I put two capacitors, different charges, resistor, you do all nonsense, you're stuck. But if this question comes in the exam, how do you guess?
Because
At
the time
t0,
constant. So we can
time
guess.
constant, at t0, charge should be 3q. At t infinity, it becomes like just like a regular circuit, isn't it?
Yes.
At t infinity, it just becomes like two capacitors connected. Then you know, they should have same potential difference. You'll be able to eliminate at least two options from there. With time constant, can you take both of them to be in series?
But yes, sir, because time constant is coming that way only.
हाँ ऐसा लग रहा है बट सीरीज तो नहीं है ना.
हाँ
वो है सीरीज तो नहीं है. आंसर इज कमिंग दैट वे. This thing ना even Arrow told me last year. He used to take, if you keep two capacitors, he used to keep them in series and हर बार आंसर आ रहा था. We tried it. Every time you're getting an answer. No matter what charge you keep, every time you're getting an answer. We couldn't understand why, but it is.
So we can use that in the
Yes.
exam, no?
I think it works out, huh? Clear with this? Clear, na? Aditya, Aryan, Ali, Arjun, got this?
Yes, sir.
Saina, Rehan, Swastika, clear? Yasha? Let's see one more. Find the charge on the capacitor as function of time t. Kirchhoff's law. There's no way out. Give it a try. Then I'll show you a shorter way to get this thing. But first, you should know how to do normally. Because if I mess up something, you always have to go back to Kirchhoff's law. The shortcut I teach you will work only for one capacitor. So always, in general, you should know. You should be quite comfortable with this level of integration. Try. Give it a try. I'll give you 2 minutes. Just get the equations at least. Just to give a simple idea, I'll tell you one thing. Let the current here be I. Let this be small I, let this be q. Let me ask you, what is dq by dt? Capital I or small I?
Small I.
Small I. बस वो याद रखो अभी करो. Means you don't want capital I in the equation. You need to eliminate that. The current, the charge on the capacitor will give you the current in that branch. Just give it a try. Get some water and come. Let me show you the equations. Let the current be I. This is I. This is I minus I. This is small I, and this is Q. Apply Kirchhoff loop law in this and in this. This would be V minus I R minus I into 2R equal to 0. So we get V is equal to 3IR minus 2IR. The second loop, it is minus IR minus Q by C plus I minus IR equal to 0. What I don't want is capital I. So I capital R is V plus 2IR by 3. Dump it here. This is minus 2IR minus Q by C plus IR is V plus 2IR by 3. Hope I'm right. Then simplify that, and then that equation would be Q by C is equal to Q by C minus 2 plus 2 by 3 minus 4IR by 3 minus Q by C plus V by 3 0. 4IR by 3 is equal to Q by C minus V by 3. I will be dq by dt, and this guy would be 3 by 4r q by c minus v by 3. So dq would be q by c minus v by 3 is equal to minus 3 dt by 4r. Initially it is 0 to q, 0 to t. This would be c ln q by c minus v by 3 by minus v by 3. I kept the limits. Minus 3t by 4r. C goes that side. I end up with qc v by 3 1 e power minus. I goofed up somewhere, kya?
Sir, in the third equation, it should be I minus I into 2R.
I minus I यहाँ पे है ना? Yeah, shit. नहीं, I minus I to R, right? The whole thing goes for a toss. I had a feeling something went wrong. This guy would be 2R. Then this guy would be minus 3IR minus Q by C plus 2IR. So that is 2 by 3 V plus 2IR. That's right. Yeah, right, Yasha. I goofed up that part. And then this will be how much? Minus 3 plus 4 by 3 minus 5IR by 3 minus Q by C plus 2V by 3. Right so far? Oof. And then what did you guys get an answer? Someone did get an answer. So keep I here and everything that side. You end up with dq by dt will be 2v by 3 minus q by c, and this is 3 by 5r. Integrate this. Two v by 3 minus q by c by 2v by 3. So minus won't come. Hmm. 2cv by 3, 1 e power minus 3t by 5rc. Fine. Yeah, Lakshika, you got it. Check this out now. This is brute force. And I can give you more complex circuit. I can put 2, 3 batteries and put 4 resistors. It becomes very complex. Now, if there's only one capacitor, you can do something nice. Your life becomes more easy. Have a look at this page. Let me show you the general shortcut. And then we can do more in the next class. All clear with this page? Everyone got what we did, right? Actually, physics got over here. Once I wrote the equations, physics got over there. Right side is complete math. Have it? Clear, no? Now, how to do this faster? Listen to this carefully. Now, you observed whenever you're solving these things, it is pretty clear the result is always coming exponential. So we can give a general result, the general solution for this is given by Q is equal to A plus B into e power minus t by tau. Here A and B are constants. Tau is the time constant. So this is a general solution for charge as long as there's only one capacitor. You can have 100 batteries and 1000 resistors, but there should be only one capacitor. So if I can find A, B, and tau, my job's done. So step 1, finding time constant. So this is what we do. Replace all the batteries with wires. The idea here is when there are no switches or nothing, right? If you remove all the batteries and make them into wires, it becomes a discharging circuit. So if you just imagine the simple case when you had one resistor and one capacitor, if you had removed the battery, it becomes a discharging circuit. If the battery, it becomes a charging circuit, and both had same time constant. So when you replace all the batteries with wires, it becomes a discharging circuit. Again, you have flipping switches and all, you can't use this thing. And find equivalent resistance across the capacitor. So the capacitor is simply thinking there's one resistor and one battery. So find equivalent resistance across the capacitor terminals. Third, then we have tau is equal to R equivalent into C. Now in our example, the one which we did just now, this is R, 2R, R, and C. To replace the batteries with a wire. So you're finding the potential across these two terminals. The 2R and R are in parallel, 2R by 3, and that is in series. So R equivalent will be 5R by 3. Therefore, time constant for this circuit is 5R C by 3. That is the first step. If you have 10 batteries, make all the batteries into wires. Step 2. This is how you can find time constant of a circuit. Again, you should have only one capacitor. Reason simple. If there are two capacitors, then you take equivalent resistance across which capacitor? If there are two capacitors, how will you take? So the whole idea here is you're replacing all that resistors
Can we
with
take
one single
equivalent
resistance.
capacitance in that case?
Again, they both should be empty and both should be in series or parallel. Then you can take. If your capacitor already some charges there, then you're stuck. Step 2. Use the initial condition. At t is 0, you know the charge is Q initial. At t is 0, Q is equal to Q initial. So this would be A plus B into E power 0. So you'll get one equation. Step 3, at t infinity, Q is Q final. That is A plus B into E power minus infinity. That is A ka value. There, you'll get all the values from there. So let's take this example which you have done just now. So this is V, this is R, 2R, R, and C. Just now we have done this today. Question number 22, we found the charge at infinity. How much? 2 CV by 3. We can calculate also. Q at infinity is 2 CV by 3. Q initial is 0. So substitute here, we get Q is equal to at t is 0, Q is 0, which is A plus B. At t infinity, Q is 2 CV by 3, which is A. So there, the general solution is A plus B, E power minus T by tau. A ka value is 2 CV by 3. And here A is equal to minus B. So that is also minus 2 CV by 3. E power minus T. Tau we just calculated 5RC by 3. We get 2 CV by 3 common, 1 minus E power minus 3T by 5RC. Which was the same answer. Is this making sense, everyone? This thing involves 3 steps. Finding time constant. You have to do little work. Step 2 is easy. Q initial will be given. Step 3, you have to do the steady state circuit. In steady state, what we do? There is no current in the capacitor, so we remove that branch and then we find the charge. So in this process, there is no need to integrate. All got this? Is the process clear? I'll give you one. You guys try. This is V. This is 2V. This is R. This is 2R. This is R. This is this plate में the charge is 3CV. T0 switch is closed here. Find the charge on the red plate as function of time t. The other plate automatically has minus 3CV. I'm not showing it. Now here you can integrate. Same thing you have to do then Kirchhoff's law, then equation, then solve. Let's try with this method I taught you, general equation. That's what I said. You had one capacitor, you can have any batteries and any capacitors, resistors. Find the charge on the red plate as function of time t. Initially, there is some charge before the switch is closed. First, find the time constant, and then find the Q final. If you got these two, question is over. If you want to do it normally, you have to integrate. Now, that's brute force. That will be little headache because there are two batteries. But that technique you should always know, because I can just mess it up by putting one more capacitor and the game is over. Which they shouldn't be doing generally. I think then you'll start getting differential equations. Try. 2 more minutes. Let's see. First, let's find the time constant. Replace all the batteries with wire. Capacitor will be here. This is not difficult. This is 2R, R, and R. So R equivalent is 2R by 3, 5R by 3. I gave the same numbers, but okay. That's 5RC by 3. At T infinity, this is how your circuit would look. All the current will go only through this. There's no current in the capacitor, but there will be some charge. Let this be Q. Why am I taking that? Because I assume that is the charge I want to find. And we can get current I is equal to V by 3R. Apply Kirchhoff loop law in this thing. You end up with V minus I into 2R. There's no current in that resistor, so that is 0 into R. And then you're going through the battery minus 2V, and then you're going from negative to positive plate, so plus Q by C equal to 0. How much is this? So this is V, I is, this thing is 2V by 3 minus 2V, that guy is 0, and this is Q by C. So Q ka value should be, how much is this? Minus 2 minus 5V by 3?
Yes, sir, same answer.
So yeah, then you're done. So the general solution is A plus B e power minus t by tau. At t0, Q is equal to 3CV. That is A plus B into e power 0. So this was A plus B. At t infinity, Q is minus 5CV by 3, and this guy is A in plus B into e power minus infinity, which is A. So A, I got it. So B would be 3CV plus 5CV by 3. 14CV by 3. Interesting. I hope that is right. Done. So Q is equal to minus 5CV by 3 plus 14CV by 3 e to the power of minus 3t by 5RC.
Same answer.
Check. Unless I messed up some calculations, but I hope the process is clear. You can see how bad is that answer. If you try to integrate, you would have got the same. It would have been a little lengthy. Yeah. So that this is the RC circuits. This is quite useful when you have, like I said, one capacitor. You can do this by integration, or you can do with this method also. Clear? So that's about RC circuits. So next class when we catch up, we will do maybe 1 or 2 more problems on this, and then we'll start off with a combination of batteries, non-ideal batteries and stuff. Non-ideal batteries, heat produced, all that stuff. So we will be left over with instruments that we can see after your MD. Okay, with this we will wrap up for the day. Do have a look at this. Ask me if there's any confusion. 5CV by 3 plus आना चाहिए ना?
I don't know, I was minus.
Plus था वो. We goofed up the whole thing again. Then 4CV by 3. Yeah. Today I'm subtractions I'm messing up. Anyways, so that's the last one for the day. So